Hello friends, in this video we will talk about development length, what development length is, why we need it, and how should we provide the development length in the reinforcement design. So starting from the beginning, as per the limit state design method, we know that we have got two limit states. So we have got two limit states. What are they? Limit state is of collapse, and the second is limit state of serviceability. So I'll not go into detail in these topics because our topics are not these but the development length. So limit state of collapse, what it says is that your structure should be strong enough to take the loads that are acting on it. Okay, and the limit state of serviceability, it says that not only your structure should be strong, it should be serviceable. For example, let's say that if this is your slab over here, and let us assume that we have designed it as per limit state of collapse, and let us assume that this is strong to take the load that acts on it. However, let's say that this slab is not serviceable because there are huge deflections and huge vibrations in this slab. Now when you enter the room from here, and if there is a huge deflection on the slab, then can you live in that room? No, you cannot live there, because psychologically you will be afraid that this will collapse. Though it will not, but you will think that it will collapse. So due to this reason, not only our structure should be able to take the load in limit state of collapse, but also should be serviceable. One of the things that you need to satisfy, or that you need to provide in order to satisfy the limit state of collapse, is the bond. So what is the bond and why we need it? So we know that we provide the reinforcement in the concrete, don't we? Yes, we do that. Let us say that this is our column over here and this is our beam. So I'll draw this section. Okay, and we know that we have got reinforcement in this beam. Now let us assume that we have provided a reinforcement like this. So when you try to pull this bar, so this is my rebar over here. So when you try to pull it from here by applying the tension force T, this will not come out. Why? Because there is a bond between the concrete and the rebar. The bond is nothing but the adhesion between the concrete and the rebar that prevents the rebar from slipping from the concrete. How this bond between the concrete and the rebar is generated? So it is generated by the following reasons. So reason number one, it is due to the friction force. So what happens is that when you pull out the rebar in this direction, then the friction force will be generated here like this throughout the rebar, and that will prevent the slipping of the rebar from the concrete. Next one is the interlocking. We know that in our structures we do not use the plain bar having a smooth surface. We use the deformed bars that do not have the smooth surface. They have got the rough structure. Due to that reason, there is an interlocking between the concrete and the rebar, and that also prevents the slipping of that rebar. So third one is the chemical addition. So the addition force is created between the concrete and the rebar, and that also prevents the slipping of the rebar. So when you apply the force on this beam from here, the force is transferred to this rebar as well, and this rebar will transfer the force from here to this column. So to transfer this load from this beam to the column, this length that you provide, the length of this rebar, it needs to be sufficient. If this is not sufficient, then the force will not be transferred to the column, and that force will be taken by the beam, and the chances are that the beam might fail. Due to this reason, the sufficient length of this rebar must be provided into the column. So how do we check whether or not the sufficient length has been provided? So as you have seen that the more the length, the more properly the force will be transferred from the rebar into the concrete, that is the concrete of the column. So how do we check this, whether or not the length is sufficient? So this thing we with the help of the development length. With the development length. So we'll talk about this in our next video.